Hello students, welcome back. So this is our lecture number 2 of carbon and its compound chapter. So those who have not watched the previous lecture, go and watch it, and don't forget to download our app Nakhyatra from the link given in the description box. There you can do the live classes, watch the recorded classes, and even online tests are also available. So let's begin today's lecture. First we will study the properties of organic compounds and the allotropes of carbon. Properties of covalent compounds. The first property is they are usually liquids or gases due to weak force of attraction between their molecules. Only some are solids. So the covalent compounds, they are usually liquids or gases. Why? Because they have weak force of attraction between their molecules. Alright, and some of them are only solids. Second point is they have low melting and boiling points except diamond and graphite. Due to weak molecular force of attraction, little energy is required to break these forces. So the covalent compounds, they have low melting and boiling points, but there is an exception. And the exception is diamond and graphite. They have high melting and high boiling points. Now since they have weak molecular force of attraction, therefore very little energy is required to break these forces. Okay, so the third point is they are generally insoluble in water but soluble in organic solvents. So generally the covalent compounds, they are insoluble in water but they are only soluble in organic solvents. Fourth property is poor conductors of heat and electricity because they do not contain ions. Yeah, the covalent compounds, they do not contain ions. So they are poor conductors of heat and electricity. Alright. Now see the occurrence of carbon. So carbon can be found in two states. One is free state and the other is the combined state. See, in free state, carbon is mainly found to exist in three forms. That is diamond, graphite and Buckminster Fullerene. And in combined state, it is mainly found to exist in carbon dioxide, carbonates, that is limestone, and fossil fuels, that is coal, petroleum and natural gas. Now see the allotropes of carbon, but before that see the definition of allotrope. The various physical forms in which an element can exist are called allotropes of the element. Yes, the various existing forms of an element bonded to each other in different manner that exist identical chemical properties but they have different physical properties. So they are called the allotropes of the element. Clear? Now see what are the allotropes of carbon. First is the graphite, the second is the Buckminster Fullerene, and the third is the diamond. Okay, now see the structure of graphite, how it looks. So this is the structure of graphite. This is the structure for diamond. And this is the structure for Buckminster Fullerene. It looks like a football, right? Next we will see the characteristics of diamond and graphite. So the structure for diamond and graphite is shown here. Now see the first characteristics. Diamond, it is colorless transparent substance having extraordinary brilliance. So as you all have seen the diamond, it is a colorless transparent substance. But in case of graphite, it is a grayish black opaque substance. So most commonly you have seen graphite in the lead of a pencil. So the lead of a pencil is made from graphite. It is a black opaque substance. Second characteristic for diamond is carbon linked to 4 other neighboring carbon atoms. So how carbon is arranged? Each carbon atom is linked with 4 other neighboring carbon atoms. But in graphite, each carbon linked to 3 other neighboring carbon atoms. Okay. So diamond has rigid 3-dimensional structure. So diamond, it has a 3D structure. In graphite, it has sheet-like structure forming an hexagonal array. See the structure forming an hexagonal array. It looks like a sheet. Okay. Now fourth characteristics for diamond it does not conduct electricity because no free electrons present. See, in diamond there are no free electrons. Therefore, it will not conduct electricity. But in graphite, it conducts electricity due to presence of free electrons. But free electrons are present in graphite. So, graphite is a good conductor of electricity. The last characteristics for diamond, it is extremely hard and heavy. And graphite, it is soft and light as compared to diamond. Okay. Now see the uses. So diamond, as you all know, it is a very precious stone that is used in jewelry. So black diamonds are used for cutting glass. Graphite is used in making electrodes, lubricants and lead pencils. So say electrodes means the electric conductors which are connected to positive or negative terminals of the battery. That means the cathode and the anode. So these are electrodes which are made from graphite. Now lubricants are substances used to reduce the friction between the moving parts. And the lead pencils, see this grayish black, these are graphite. Alright, now next is fullerene. So it is an allotrope of carbon. It has a formula C60, arranged in the shape of a football. See, it does looks like a football. Similar, right? It looked like a geodesic dome designed by US architect Buckminster Fuller. So this is the US architect Buckminster Fuller. Next we will see the versatile nature of carbon, catenation, tetravalency and types of organic compounds. See the versatile nature of carbon. Carbon forms covalent bonds. The nature of these covalent bonds enables carbon to form large number of compounds. So we know that carbon forms covalent bonds. So because of that nature, carbon enables to form large number of compounds. The number of carbon compounds are recently estimated to be about 3 million. Now what could be the reason for this? So the two factors responsible for large number of carbon compounds are catenation and tetravalency. So first we will see catenation. So it is the property of self-combination of atoms to form large molecules is called catenation. So catenation means bonding of atoms of the same element in series. See the example is given here where one carbon is linked with another and forming a series. So that is called catenation. So it can be branch chain. See here it is a branch chain or it can be a closed chain. It is closed like structure, right? So it can be a closed chain. Carbon atoms may be linked by single, double or triple bonds. See in this structure, carbon atoms are linked by single bonds. In the second structure, the carbon atoms are linked by double bonds. See here, double bonds are linked. In the third structure, the carbon atoms are linked by triple bonds. See, these are the triple bonds. Now the elements that show catenation. What are the elements that show catenation? We will see. First is carbon, then sulfur. See, this is the structure of a sulfur molecule, S8, formula S8. Third is silicon and fourth is phosphorus. So these are the elements that show catenation. Carbon, sulfur, silicon and phosphorus. Next is tetravalency. Since carbon has valency of 4, it is capable of bonding with 4 other atoms of carbon or atoms of some other monovalent element. So see, one example is given here where carbon is bonded with chlorine. So before that, I want to tell you that monovalent element means any atoms having their valency 1. So here the chlorine atom, it has a valency 1. At the beginning of the 19th century, compounds obtained directly or indirectly from plants, animals, and organic compounds obtained from minerals, inorganic. Now see, for organic compounds, it was postulated that a vital force was necessary for their synthesis. German chemist Wohler, in 1828, he made urea from ammonium cyanide. Here urea, which is an organic compound, and ammonium cyanide is an inorganic compound. Organic compounds refers to all compounds containing carbon and hydrogen which are obtained from living system, and nowadays which can also be synthesized in the laboratory. So the organic compounds that contains the carbon and hydrogen which can be obtained from the living system, and nowadays it can also be synthesized in the laboratory. In the next slide, we will see the types of organic compounds. First is hydrocarbons. So hydrocarbons comprised of carbon and hydrogen. Second is haloalkanes. Alkanes containing one or more halogen substituents. Third is alcohol. Fourth is aldehyde. Fifth is ketone. So see, the alcohol, aldehyde and ketone, these are the functional groups. We will study later on. The last is vinegar. So these are the types of organic compounds. Now we will study about hydrocarbons, alkane, alkene and alkyne. First we will see hydrocarbon. Compounds containing carbon and hydrogen. So one example is showing here where the carbon are bonded with hydrogen. All organic compounds contain hydrogen along with carbon. They are the fundamental organic compounds, also known as parent compounds. These compounds are known as hydrocarbons. Now hydrocarbons are of two types. One is the open chain hydrocarbons and the other one is closed chain or ring cyclic hydrocarbon. So the open chain hydrocarbons are divided into two types. First is saturated. So first see what is the definition of saturated hydrocarbon. A hydrocarbon in which the carbon atoms are linked to each other only by single bond. It is called saturated hydrocarbon. So it is called alkane where carbon atoms are bonded with a single bond. See here. These carbon atoms are linked with a single bond. It is called alkane. The second type of open chain hydrocarbons is the unsaturated hydrocarbon. So a hydrocarbon in which the carbon atoms are linked to each other by double or triple bonds are called as unsaturated hydrocarbon. So unsaturated are of two types. One is the alkene where carbons are linked with double bonds. See here, these carbon atoms are linked with double bonds. And the other one is alkyne where carbon atoms are linked with triple bonds. See, these carbon atoms are linked with triple bonds. Okay. Now first see alkane, alkene and alkyne. So alkane means carbon atoms are linked by single bond. In alkene, the carbon atoms are linked by double bond. And in alkyne, the carbon atoms are linked by triple bond. Alright. So the general formula for alkane is CnH2n plus 2. And for alkene, CnH2n. Here see, in case of alkenes, alkene contain 2 hydrogen atoms less as compared to corresponding alkenes. And for alkyne, the formula is CnH2n minus 2. In case of alkynes, the 2 hydrogen atoms are less as compared to corresponding alkenes and 4 hydrogen atoms less as compared to corresponding alkenes. See here, this N means number of carbon atoms, and here this N means number of hydrogen atoms. Alright. Okay, now see, in alkanes, the suffix ane indicates single bond. In alkenes, the suffix ene indicates double bond. And in alkynes, the suffix yne indicates triple bond. But as you can see, ALK is common for all. So it represents the number of carbon atoms and is called a root word. Next we will see the compounds contain the number of carbon atoms and their root words. So first, compound with 1 carbon atom and the root word is mit. Compound with 2 carbon atoms, the root word is it. And the compound with 3 carbon atoms, it is prop. Compound with 4 carbon atoms, it is but. Compound with 5 carbon atoms, pent. Compound with 6 carbon atoms, hex. Compound with 7 carbon atoms, hept. Compound with 8 carbon atoms, oct. Compound with 9 carbon atoms, non. And compound with 10 carbon atoms, dec. So these are very simple. Please try to remember it. Alright, don't get confused. So it is mit, it, prop, but, pent, hex, hept, oct, non and dec. Okay guys, this is the last slide of today's lecture. So here we will see the formation of hydrocarbon. The structure for methane is given here and the methane has a molecular formula CH4. But as we can see that the number of carbon in this molecule is 2, so met will get replaced by it and the compound will become ethane. In the next compound we can see that the single bond has been replaced by a double bond. So ANA gets replaced by ENE and therefore the compound will become ethene. In the third structure, see that here the single bond has been replaced by triple bond. So ANA gets replaced by YNE and the compound will become, can you name the compound? It will become ethyne. So alright students, we are done for today. Thank you.